Abdul Meet. My group consists of three members: Muhammad Salman, myself, and Muhammad Abuzar. So, I handle the data engineering and mathematical foundation. My role was to convert the unstructured data into structured mathematical format to model the economic connection between Pakistani cities. The first step is to normalize the data and calculate similarity matrix. Since the price vary widely like wheat versus electricity, I applied the min-max normalization. This scales all values between 0 and 1, ensuring that the high price do not skew the result. We care about the trend, not the raw cost. So for this purpose, I just made a code. Or this code helped me to normalize the unstructured data into the structure form, and we conclude to make a PDF of the structured data, normalized and clean finalized data, which help us to find the similarity matrix and other things. After the normalization, we just have to find the defining relationships, binary relationships, and other things. Cosine similarities for the core matrix. I use the cosine similarity. We treat cities as a vector in multiple dimension space. The formula calculates the angle between a score of 1 means identical price behavior, 0 means no relations. Conclusion: my final output is this weightage adjacency matrix. These clean mathematical representations are now ready for member to build a network graph and perform temporal analysis. I will show you the similarity matrix. These are the similarity matrix that I have built, and some binary relationships are in it.
Hello, Assalamu alaikum. My name is Muhammad Salman, working as a member 2 of this project. I have started working after receiving the data from the member 1, which is Moid Alvi. Now my first task is the parse similarity data and build price similarity network. Using this Python code and the threshold value of zero point 0.7, I have generated a total of 140 graphs, which you can see in this folder. Basically, 140 graphs. These 140 graphs shows the hard work and dedication. Shows our hard work and dedication to this course. Then moving towards the next task, which is temporal analysis. This code, this Python code gave us a temporal analysis report. Now, this code outputs will tell us reflexivity, antisymmetry, and transitivity. All three things are satisfied, and we know that if all three things are satisfied, then temporal relation is a partial order. Then moving toward the third task, using this detailed Python code. This Python code is basically is for degree of centrality, closeness, betweenness, and eigenvector. On running this code, you can see the result. The detailed output will be saved to the graph and centrality summary.csv, and centrality analysis completed successfully. Our fourth task is drawing a haze diagram. Using this Python code and the network library, we have we have drawn a very beautiful and detailed haze diagram, which is here. Yeah. This diagram will display a relation between different cities and very clearly. Now moving toward the next task. Basically, this code is only for showing that my all tasks have been completed and then transferred to the member 3. Now the things I have done is drawing all the graphs, centrality degree, closeness, betweenness, eigenvector, centrality summary.csv, and temporal analysis report and his diagram. All the things have been completed for the member 2 and then transferred to the member 3 for continuing the project.
Assalamu alaikum. I am member 3 Muhammad Abuzar. My focus in this project was weighted centrality aggregation. While previous members built their initial networks, raw centrality scores are often noisy. My objective was to filter this noise using discrete mathematical modeling to find the true economic hubs of Pakistan. The methodology and code I have used is shown in this part of the video. So basically to do this, I implemented four specific mathematical models in Python. For correlation weighting, I calculated the correlation matrix to mathematically reduce redundancy between similar matrices like degree and closeness. For entropy weighting, I used Shannon entropy to assign higher weights to matrices with higher information variance. For category importance, I applied economic alpha values, giving food a 35% weight versus clothing a 10% to match the real-world CPI index. Now let's check this code by running it in the Python file. I've also built an interactive module to test economic hypothesis live. Let's say we want to ignore raw popularity and strict hunt for structural bridges. I manually set degree to zero point 0.1 and increase betweenness to zero point 0.7. The ranking updates instantly. This proves our code is flexible enough to answer dynamic economic questions on the fly. Now let's visualize the images that this code have generated. Talking about the heat map, our similarity heat map confirms that Pakistan's market is segmented into tight regional clusters, shown here in deep red. Now let's visualize the network clusters. Filtering for strong edges reveals a small world topology where specific hubs pull smaller cities into their orbit. Now let's visualize the ranking chart. Finally, our comparison chart. Note the green bar. This is economic impact score. Despite the penalty from CPI weighting, Sargodha and Gujranwala remain the top hubs. This identifies them as the primary price setters for the nation. To conclude the project, I would say our weighted analysis proves that inflation propagation is structural, not random. These identified hubs are the critical points for monitoring national price dynamics. Thank you.